Welcome back. For today's video, I wanted to start off with giving you a big congratulations because today we are finally at our very last lesson of the year. Yes, that's right. Today's lesson is the very last notes that you will take for this year. And then the remaining weeks we have left of school, we're just going to be doing reviews and reflections. Okay, so congratulations, you have all worked so very hard and I appreciate all of the work that you have put in this year. And this is our last lesson, so why don't we go ahead and get started. So the very last lesson of the year is called the imaginary number. So go ahead and title your notes, imaginary number. So let's take a look. Imaginary number, which is notated by the letter I, is equal to square root of -1. So let's think about that. Because remember in the beginning of the year, I had told you when we're learning about square roots and cube roots that we can't take the square root of a negative number, right? But actually I lied, you can. And square root of a negative number, as you can see here, is called the imaginary number. And the imaginary number, like I said, which is notated by the letter I, is equal to square root of -1. So using this information, let's go ahead and take a look at an example. So here we have example 1, simplify square root of -4. Normally we would have said, well, we can't take the square root of -4 because two same numbers when they're being multiplied, whether it's positive times positive, that's equal to a positive, or negative times a negative, that's also equal to a positive. It doesn't make sense for a square root to be a negative number. But using the imaginary number, what we can do is you could break this apart. So square root of -4 can be broken apart as square root of -1 times square root, my pen's frozen, okay, sorry. Square root of -1 times square root of +4. Because -1 times +4 is -4, right? And then we know that -1 is equal to the imaginary number, which is the letter I. So the square root of -1 turns into the variable I, and then square root of 4 stays the same. Square root of 4, we know, is a perfect square, is 2. So this actually turns into imaginary number I times 2. And then when we write our final answer, usually the number comes in the front, so we would say 2I. And then we box it, that's it. And that's our final answer. So let's take a look at another example. So the example here is to solve this quadratic equation. 8x squared plus 6x plus 5 is equal to 0. We're going to use a quadratic formula to solve this equation. Remember, the first step to solving a quadratic equation is to identify what is our a, b, and c. So let's go ahead and do that. So in this case, our a is 8, b is 6, c is 5. So knowing this, let's go ahead and plug it into the formula. So we have x is equal to -b, b is 6, plus or minus square root of b squared, that's 6 squared, minus 4 times a, which is 8, times c, c is 5. And then all over 2 times a. 2 times a is 8. So let's go ahead and simplify that out. So we got x is equal to -6 plus or minus square root of 6 squared is 36 minus 4 times 8 times 5. So if we go ahead and multiply all of these numbers together, you get 160. 160. Well, it's -160, so I put the minus sign here. Divided by 2 times 8 is 16. And let's go ahead and simplify it out further. Oops. So we got negative 6 plus or minus. Inside the radical, 36 minus 160. 36 minus 160 gives you negative 124. Divide that by 16. So then from here, what we're going to do is we have a negative number inside the square root. So that's like what we saw here, right? In the beginning when you had a negative 4, we're going to go ahead and do the exact same thing as we did in the previous example. So then what you get is x is equal to negative 6 plus or minus. Square root of negative 124 can be divided up into two different radicals. Negative 1 times positive 124 all over 16. And we know what this is equal to, right? That is equal to the imaginary number I. So then what happens is negative 6 plus or minus I square root of 124 is equal to 16. And then we could stop here, but square root of 124 could be simplified even further. So we're going to go ahead and simplify it all the way, okay? So if we go ahead and simplify it all the way, that's negative 6 plus or minus I square root of 124. Remember we did this last time? Two numbers that multiply to 124, and one of them has to be a perfect square. I'm thinking 4 times 31, because 4 times 31 is 124, and 4 is a perfect square. So we could break that apart. So then if we break that apart into two separate radicals, that's square root of 4 and square root of 31. And now, because this is a perfect square right here, we can go ahead and simplify that. So then what you get is negative 6 plus or minus square root of 4 is 2. So we can say 2, keep the I, 2I square root of 31 all over 16. Again, for those of you that are confused, we have simplified the square root of 124. Remember, to simplify radicals, you think of what two numbers multiply to give you the number inside, and one of the numbers has to be a perfect square. In this case was 4. 4 times 31. Square root of 4 is 2, so we took the 2 outside of the radical, put it in the front of the I, and the square root of 31 is not a perfect square, and we cannot simplify it any more further, so we leave it inside, okay? And then from here, now you ask yourself, can I simplify anything more? What I'm noticing is that all the numbers on the outside, these numbers are divisible by 2, right? So we're going to go ahead and divide those three numbers by 2 and then see what we get. So then negative 6 divided by 2 is negative 3 plus or minus 2 divided by 2 is 1. So it goes away. I square root of 31 all over 16. 16 divided by 2 is 8. Okay, and then from here, I don't see anything else that can be divided. 3 and 8 cannot be divided. 31 cannot be simplified. So we've simplified everything as much as we can, so we are finished. So here, this is our final answer. So I'm gonna go ahead and box it. Now we are finished, okay? All right, so that was the very last lesson of the year. Congratulations again, you guys. You've worked so hard and I'm very, very proud of you. Good job on coming this far. Hopefully, the notebook will come useful for you so you don't throw it away. And then maybe next year you can use it when you're in high school. All right? Okay. Bye, everyone. Good job.